Oh, good morning to Doctor. We are from Group G, the Great Gatsby of Facility Design. Today we are going to present our project to, which is uh, our group member Muhammad Asri bin Kamarudin, myself, Amisha, and Najifa in Sasabi. So there are two products selected for our case study. They are multi-function sofa bed and wooden shoe rack. So the case study background are the challenges in optimizing resources for producing wooden shoe rack and multifunction sofa beds within the same factory. And we also need for an efficient factory layout to enhance the workflow and safety. Next is the objective and scopes. There are four objectives. First one is to utilize facility design techniques to create efficient factory layout for the production of wooden shoe rack and multi-function sofa beds. The next is identify and apply the most suitable facility design techniques, approaches, and concepts to optimize space and resource usage. The third one is recommended the most effective factory layout and supportive facility based on comprehensive evaluation of all alternatives. Last one is design layout that streamline production process and enhance workplace safety, complying with relevant regulation and standards. There are three scopes. The first one is creating layout suitable for wood-based, metal-based, or hybrid wood and metal-based manufacturing. The second one is redesigning the factory layout to mitigate workflow disruption, safety hazard, and inefficiency in material transport. Lastly, the project only covers suggestion and no real-life implementation. Next is the assumption. So there are seven assumptions. The storage and warehouse size assumed to be 5 meter times 10 meter. The department size assumed to be 5 meter times 5 meter. The cost assumed is 1 ringgit per meter. The value of sofa bed or similar product market in Malaysia is 100 million, and the sofa bed represent is 10% of this market. The value of home organization product in Malaysia is 50 million, and the wooden shoe rack represent 5% of this market. The manufacturer aims to capture 5% of market share of both sofa, bag, and shoe rack. The manufacturing process operates 8 hours per day and 22 days per month. So this is our product structure for the wooden shoe rack. There are three layer level, which is level 0, level 1, and level 2, which have shoe rack, frame assembly, and shelf assembly. And they are also have their sub assembly. So this is the bill of material of wooden shoe rack. We have the bill material of shoe rack, the bill material of frame assembly, the bill material of shelf assembly. Here we are we have the source of buying or making. And this is the product structure for multi-function sofa bag. So they have frame assembly, bagging assembly, and hidden table assembly. They are also sub-assembled under the assembly. Now this is the bill of material of multi-function sofa bag. The first one is the bill of material of the multi-function sofa bed. The second one is the frame assembly. The third one is the bagging assembly. And the final one is the hidden table assembly. So next I'll be passing to Najifa.
Okay, so this is the process chart for the wooden shoe rack where it started with the stored wood at the raw material storage, and important processes in the shoe rack manufacturing include wood cutting, drilling, gluing, sanding, painting, and also the assembly. Here the assembly process include attaching top panel to the side panel, to the cross support, and also to the shelf panel with the support, and then become the shoe rack assembly. And then it finalized with the inspection, packaging, and finally sent to the customer. Next slide. Uh, Here is the process chart for multifunction sofa bed, which raw materials include several types such as metal, wood, leather, cotton, slide rails, and hidden components. And the process of the manufacturing sofa bed is quite extensive compared to the wooden shoe rack. Next slide. These parts are then assembled into three sub-assemblies, which are the chair assemblies, bed assemblies and also table assemblies. And then the final assembly of sofa bed is sent to the warehouse and waiting to be purchased by the customer. So next slide. This is our process layout for the manufacturer, for the manufacturing that produce two distinct product, which is the Shurek and also the sofa bed. Basically, they have several process that are similar. So for both product, they have some process that are the same. And then for the placement here, we locate storeroom and also for the raw material and also for the finished product at the very left and also at the very right. And so between them is the department for the processes. And then here we can see that there is the arrow that indicates the process sequence. Next slide. This is the process sequence layout shown here for each product, and there are uh, processes A until P, and also the monthly demand for each product is 78 and 78 Shurak and also 53 sofa bed. So this number is determined to so that the manufacturing can achieve their aim for the market share. Next slide. This is the from to chart. So basically, this from to chart is showing the material flow with the number of with the number of product that need to be moved from each department to the other. So let's take example from department A to department C. There are 78 shoe rack and also 53 sofa bed that need to be moved because it indicates that both products need to go through either from A to C or from A to C. So next slide. This is the step two from the from to chart. So here we just total up the total up the amount of the unit that need to be moved from one department to each other. So earlier we see that from A to C there are 78 plus 53. So here we total them up and it becomes 131. And then these numbers from the chart will be later used for the next method to improve the layout. So next slide. This is the space requirement for each department. Basically, we use the largest space for the warehouse space, which the size is 5 times 20. And then so the larger the larger places is also used for the raw material stores, including for the wood and metal. And then between them, the departments are the area ranging from 12 meters squared and until 36 meters squared. Next slide. So this is our first method to improve the layout. This is the pairwise exchange method. The strategy that we applied here is that the storage places A, B, and P won't be moved, so they stay there. And for the process department from C until O, we categorize them into two sizes: small boxes 5 times 5, which are CGIO, JN, and also LM, and also large department with size 10 times 5, including E, F, and K. The exchanges only will be done with the between same size department considering the availability of space. So we do not exchange C with E, for example. And from the overall iteration of exchanging the department, this is our improved layout that incur only 13,660 ringgit from the initial incurred cost of 13,785. So next will be continued by Asri.
The next one is SLP method. Since our station 15, so we get our number of relationship is 105. So this is the table that represent the rating of each one. A is absolutely necessary. E is especially important. I is important. O is ordinary importance. U is unimportant, and X is undesirable. So the amount of A is 5, E is 11, I is 16, and the other are O, U, and X. Next slide. So this is the relationship chart for each one, and also the rating. Next slide. After that, we can represent it with layout chart, layout from relationship chart. So you can see that 4 lines represent the relationship that is rated as A, and 3 lines represent a relationship that rated with E, and I represented by 2 lines. And the bottom one is the uh, layout relationship chart with space value. Next slide. So what did we change is we change G with H and J with I. So the initial material movement is 13,785 ringgit, and for the improved one is 11,253 ringgit. So that is 18% improvement. Next slide. Next part is line balancing. We use largest candidate rule. So this is the precedence diagram with the time for each station and its precedence. Next slide. So according to largest candidate rule, we need to arrange it by descending time. So we can see the first one is M. Has the largest number. And lastly, P, which is the smallest number. So the daily production is 5.65 units per day, and cycle time is 80 minutes per unit. Next slide. After we consider the number of total time is less than 80 minutes, we got 3 different stations. First station, A, B, C, D, E, G, I, and F. So the total time in station 1 is 78 minutes, and the idle time is 2 minutes. For station number 2, we have H, J, K, and M. The total time at station 2 is 62 minutes, and the idle time is 18 minutes. And lastly, station 3, we have 80 I'm sorry, 50 minutes, and the idle time is 30 minutes. So the total time for overall process is 190, and the total idle time is 50 minutes. Next slide. So this is our precedence diagram with the drawing of each station, station 1, 2, and 3. So the value of line balancing loss is 20.83%. Next slide. And lastly, so for the conclusion and recommendation, our goal is to enhance space utilization, to improve flow efficiency, and ensure compliance with safety regulation. Our challenges is inefficient current factory layout and workflow disruption and potential safety hazard. For the line balancing method, which is largest candidate rule, the total visit time is 190 minutes. Cycle time is 80 minutes per station. Total workstation are 3. Idle time is 50 minutes. And value of line balancing loss is 20.83%. And from to chart analysis, the initial material movement cost is 13,788 ringgit, and the improvement is 13,660 ringgit. So we use pairwise exchange method. And the next one, for SLP method, the improved layout cost is 11,253 ringgit. And lastly, for recommendation, we need to refine task allocation to reduce idle time, and then explore alternative line balancing technique. For example, rank positional weight method. And lastly, regularly update from two chart analysis to minimize transportation costs. And that's all from us. Thank you.